Good morning. Hopefully you can see me drinking a cup of coffee and got some music going in the background. It's my music, so let me pause it. You can see that I got a double screen going on and all kinds of stuff happening here this morning. Hope you're doing well. Algebra, we're going to review some things on a double screen here, review some things for equations. All right. As we said last week, now I know that we got to get through equations and then we were going to lead into the study of powers and things like that, but I want to make sure that we're good with the more complex equation solvings that we might see. So essentially today, all you're going to do is take notes. I'm going to give you about, I don't know, 8 or 10 equations. We're going to do them together. I want you to do them at your seat, and it should be refresh your memory. So, okay? All right, well, let's get it going here on, get out of this side-by-side mode. You don't need to see me. Let's pull this up a little bit more. And today, again, is Tuesday, and it's 8:17, and we are talking about equations. Remember, we're going to have some common terminology, but let's just start off with a simple one. 3x minus 8 is equal to 2x plus 4. Okay, so there's a simple one. The first thing we need to recognize is that we have variables on the same side. My dad joke or math joke is we got to get the x's together. That's hard to do sometimes. Hard to do sometimes to get the x's on the same side. But that's what we got to do, and I like that we have a 3 and a 2, and so I would subtract 2x here just because that gives me a positive coefficient. That's a new term I don't think I've referred to yet. Coefficient, and that is the number in front of the x. That's the value in front. If we just have a variable, then remember there's a 1 in front of there. Don't be surprised at that, so the coefficient's 1. But 3 minus 2 gives us a 1x. I don't have to write the 1 if I don't want to. Then I have negative x, and that's equal to, then that's positive 4 because that plus stays with it. Again, I don't have to write that. All right, and so here we have it. Now we're trying to isolate the variable at this point. Isolate variable. Whatever they're doing, we have to undo. They're subtracting 8, so I'm going to add 8. Whatever I do to one side, I have to do the other, and I end up with x equals 12. That was a pretty simple one. Let's do another one. Okay, so let's say we have x over 15 plus 7 equals 4. Okay, so now this is a little different. What are they doing to our variable here? They're dividing by x and they're adding 7. We have to undo in the same order that we would do PEMDAS. So since we have addition, we need to go ahead and subtract. We have to isolate the term. Here is the term. We have to isolate the term. That's the term that's isolated. Subtract 7 from both sides. So now I have x over 15 is equal to negative 3. Now to undo a multiplication, we want to multiply by 15. Whatever I do to one side of the equation, I have to do to the other side. So the 15s will cancel. And so I have x is equal to negative 45. Now remember, we can always check. I can always check. I can go negative 45, put that into, or replace x with that, go 15 plus 7 equals 4. Negative 45 by 15 is negative 3, plus 7 equals 4, 4 equals 4, check, check. We are good. All right, let's do another example. Okay, so let's say we have x over 2 plus 4 equals x minus x over 2 minus 8. All right, well, the first thing we got to do is get the x's on the same side of the equation. I don't know here. Let's subtract this one over here. So we'll go x over 2 minus x over 2. Now, that's the same thing. So if I take x over 2 minus x over 2, they literally cancel. And so I'm left with 4 is equal to negative 8. That gives us no solution. There's no value of x that we can put in that would make this equation true. That's kind of a different one. Let's do another one. Okay, so what happens if I have 3 over 4x minus 7 plus 5x equals 10? Oh boy. So now I've got 2 terms with x's. I've got to combine those terms. Combine like terms. Combine like terms. Combine like terms. Okay, so let's do that. So I have 3/4 x plus 5x. That's adding 5 3/4, okay, which gives us 5 3/4 x. You can't get a common denominator. Let's do a quick review for fractions. 5 plus 3/4. I want to get a common denominator. This becomes 20 over 4. 20 over 4, add across. 20 plus 3 over 4, which is 23 over 4, which is 5 3/4. All right, so back to this. 5 3/4 minus 7 equals 10. Now I want to isolate the term with the variable. That means I'm going to add 7 to both sides. So 5 3/4 x is equal to 17. To undo whatever they're doing, I'm going to divide by 5 3/4. 17 divided by 5 3/4. That's an ugly complex fraction. Let's fix it. So I have x is equal to, that means I multiply by the reciprocal. 5 3/4 we already know is 23/4. So I multiply by the reciprocal of 4 over 23. Whenever I divide by a fraction. 17 times 4 is 68 over 23. You could leave it like that, although that's not simplified. What is that? 3 wouldn't work. It's 2 and 22 23rds. What a doozy that one was. 2 and 23 23rds. 22nd 23rd. I gotta grab a coffee. Drink my coffee. Okay, here we go. Clear as mud, huh? Love fractions, don't we? Let's do a few more examples with fractions. What if I have to use the distribution property? So 5 x minus 7 plus 3 x minus 8 is equal to 7 x plus 4. Now let's solve for x. Well, the first thing I gotta do is distribute. I love using arrows. X, put those all the way in. That's the visual that we've got. And so when we do that, 5 times x is 5x minus 35, and then 3x minus 24, and then 7x plus 28, the distribution property. Now I got to combine like terms. I got 5 and I got 3. I got 8x. Minus 35 minus 24 is minus 59. And I have 7x plus 28. Let's get the x's on the same side. Sometimes that's not easy. I'm going to subtract 7x from both sides. 8 minus 7 just gives me x. I don't have to write that 1 out in front. X minus 59 is equal to 28. Now I add 59 to both sides. And x then is equal to 87. Nice. X equals 87. All right, questions? All right, I think if you have any, we're not live, are there? So just a habit of mine to ask if there are any questions. If there are, make sure that you send me your email. All right, so here's what I want you to do. The notes that we just took. Okay, so here and here, I want you to send me that. Send notes as assignment. Send notes as assignment. Okay, that's it. Have a great Tuesday. Have a great Tuesday. All right, send me the notes of the assignment, and we're going to keep moving along here. You guys are doing a great job. If you don't have your book, make sure you come into the school, try and get everything ready. Okay? All right. Signing off.